Good morning, dear children. So now we are moving on to our sixth module, and the sixth module is generally dealing with mainly two aspects. One is regarding the building failure and the other one is regarding the structural failure. So in this video we will be dealing the building failure. So in the case of this building failure, we will be dealing with the topics such as general reasons for the failure, classification of the failure, then causes of failure in RCC and in steel structures, then the failure due to fire, wind and earthquake. So these are the basic things which we will be dealing in this video as well as the PPT. So what is basically a failure? As we all know, failure means a breakdown, isn't it? So this failure can be defined as a breakdown in the operation, function, quality or appearance of a structure, system, component or material. So these breakdowns may occur in the operation, it may occur in the function, it may occur in the quality or appearance of the structure and also the system, components or the materials. Okay, and these failures have been found in all types of buildings. Okay, and this common failure are due to the water entry, structural failure and also the fire. Okay, so this structural failure may be due to the usage of unsatisfactory material, may be due to poor fabrication and maybe due to poor erection, then maybe due to the faulty design, foundation moving and also the overloading and fatigue conditions. So now let's see the general causes of failure. Indeed, like the general causes of failure means inappropriate material is being used for the construction. That means we will be using substandard material or wrong material is used for construction. The second one is due to the bad workmanship. That bad workmanship means that when we incorrect like a concrete or mortar mixes. So while they are preparing the mixes, they might not have done it based upon the correct proportion. Then concrete and steel in the required unit of structural construction is omitted. That means they will not be using proper concrete or steel for the construction. Then foundation not matching the load of the founding condition. Sometimes when they go for the foundation, as per the design, they might have told such and such situations are to be considered and such reinforcement has to be done. So might be they might not go for it in order to reduce the cost and all, and they will go for lower like foundation. So if it is not matching the load, the foundation is not matching the load which is coming over it, surely the building will collapse. Then the rot or insect which damages the timber and the buildings. Then if the reinforcement is is omitted in certain situations, that may also result in the collapse of the building. Then bad design is a basic thing which usually result in the collapse of a building. That means the bad design it may not allow a proper movement. That means proper joints might not have been provided in such buildings. If the proper joints are not provided in the building, as you know that this temperature changes may cause expansion and contraction and finally it will crack. Okay, then if they are not providing a proper means for the storm control or like a proper drainage is not provided, that will also result in the collapse of the building. That is, it may erode the foundation and all. Then trees or the roots which damages the building, that means no proper maintenance is being done. So if the no proper maintenance is done on the if the trees are getting into the foundation, if the roots of the trees are getting into the foundation, it may also cause a problem to the building. So proper maintenance of the trees and also the buildings is very much required. Then if no slip joint is provided between the concrete and a supporting brickwork, that will usually causes cracks. So proper slip joint means proper joint should be provided. Okay, then natural catastrophes such as cyclone, tsunami, etc. and man-induced catastrophes, etc. will result in the building failure. Okay. So now let's see. So these are the what we have seen is the factors which affect the collapse of the building. Now let's see how these building failures can be prevented to a certain extent. So the first point, let's see, if a proper structural design is being provided, okay, that means the structural design which is prepared by the engineer must be cross-checked by another engineer appointed by the municipal corporation. This will prevent the faulty structural design that may result in the building failure. So if the design of an engineer is being rechecked by another person, so if some of the things might have been omitted by mistake or by involuntarily, that they might have omitted some of the aspects, so that may cause failure of the building. So if it has been found by another engineer while he is checking it out, it could be corrected and that problem could be avoided. Then the site execution of construction work, especially with respect to RCC work, must be supervised by an external licensed supervising engineer appointed by the municipal corporation. So while doing the site work also, there should be someone to inspect it, whether they are using the correct materials, good quality materials. So that will also, the proper monitoring will also prevent the collapse of the building to an extent. Then soil investigation report of the site must be made mandatory and it must be conducted by a reputed institute or a laboratory. This will reduce the risk of building collapse by foundation failure. Okay. Then the next point is the final copies of design and drawings must be given to the owner of the building for safekeeping, which will become useful when any structural repairs are to be done in future. So suppose we are the design and the drawings of our building should be kept in a safe custody. So when there is any mishappenings or when there is any failure which occurred over there, then it could be checked and it will be easy for maintaining the maintenance work also. So any structural repair work or addition of new floors must be done only after consulting the structural engineers. Next point is, for all buildings and which are showing signs of deterioration, immediate health checkup must be carried out. Okay. So suppose a building is in a deteriorated stage, then its checkup should be carried out so that this collapse could be prevented and also the people could be evacuated from that building. Then let's see the different types of this construction failure. So this construction failure are of different types. The one is the failure of the concrete structures, component failure. Third one is fundamental failure. Fourth one is non-progressive failure. Fifth one is progressive failure. Sixth one, economic failure. Seventh one, aesthetic failure. Eighth one, structural failure. Ninth one, functional failure. So these are the main failures which are happening in a building. So these are the construction failure or the failures which results in the collapse or the failure of the building. Okay. Now let's see the failure in the concrete structures. Okay. So when the mixed components such as cement, fine aggregate and coarse aggregate are of less value or standard, there is a tendency that the concrete structure will fail because of the inadequate mix ratio of the component. Okay. And moving on to the component failure. This component, that means the building components tends to fail depending on the materials, design, method of construction, environmental conditions and the use to which the building is put. Then let's see the causes of component failure. So using of substandard material and design error, that is the method used in designing the building, whether if no proper method is being followed in designing a building, proper code is not followed in designing a building, and when the materials that are less in quality is being used in the building, okay, that will result in the collapse of the building. So that is the component failure. Next is the foundation failure. Okay, this foundation failure can cause the building to collapse. Okay, The foundation is the first element of a building where the construction starts. But when it fails, it can cause many defects in the building, including failure or collapse of the building. So repair of defect in foundation are most difficult and very costly. So it is most important to understand the type of foundation failure to avoid them by taking necessary steps before the construction starts. Now let's move on to the non-progressive failure. This non-progressive failure or condition is the one that is not likely to deteriorate. Generally, the non-progressive failure of an under-specified component such as building insulation can result from design or construction defect that often do not need to be remediated. Then let's come to the progressive failure. This type of failure is one that is likely to worsen over the time. In the legal and insurance field, a progressive failure, that is the basis of a defective work claim, is often described as a continuous loss. Defects such as expansive soil under a basement slab can cause structural and progressive slab failure and may need to be corrected as soon as possible. Then what are the main causes of this progressive failure? One is the miscommunication between the contractor and the engineering document. This contractor should thoroughly follow the engineering document regarding the mixed proportion, the components, or the how much RCC, how much reinforcement should be given. So how much load this building has to carry, and how much strength the foundation should be given. All this aspect he has to completely move on with the conditions which are provided in the engineering document. Then next is due to the improper inspection or overlooking structural issues also lead to progressive failure. If the structure go for years without receiving proper maintenance, rust or other material failure can occur, which weaken the structure and make it more susceptible to the progressive failure. Now let's move on to the economic failure. This is the condition that results in economic loss or the need to expand unplanned moves to keep a structure, component or system in order. The loss could take the form of excessive maintenance, shortened useful life or added repairs. Now let's move on to the aesthetic failure. A condition that renders a component unsightly, significantly detracting from its appearance, can be termed as an aesthetic failure. That means the appearance of the building get affected. That means the good appearance might have completely gone. So that is an aesthetic failure. These economic consequences often accompany this aesthetic failure, such as masonry effective, although there may be subjective and difficult to the quality. Next is the causes of aesthetic failure, that is rise of dampness, then pilling of paint caused by water or due to a void which is being created and while mixing, and also the while casting the materials, that means a proper mix might not have been used, so the surface may appear to be bad. So that is also a reason for this aesthetic failure. Now let's move on to the structural failure. So this failure, that means the structural failure, is a breakdown in one or more components of the structural system. Such failure includes common concrete cracking, which may or may not be of any consequences depending upon the degree of failure. In addition to the structural failure, this structural failure do not always require correction, and in the context of construction, defect claims and litigation, a structural failure without some functional failure or impartial is of limited value. Then the failure of structural steel connection caused by design defect could be a catastrophic and demands immediate attention. So the defect which might be caused due to the improper design of the steel needs a great attention, so that the further issues could be solved to a great extent. Then let's see the causes of structural failure. So this structure is not strong and tough enough to support the load. This structural failure from fatigue or corrosion caused by instability in the structure's geometry, design, or material properties. Structural failure is caused by manufacturing errors, improper selection of materials, incorrect sizing, improper heat treating, failing to adhere to the design, etc. And the structural failure may also occur due to the use of defective material. Then the another reason is that lack of consideration of unexpected problem that might be caused due to the natural disaster is also a reason for the structural failure. Now let's move on to the functional failure. This is a condition that renders a component unsuitable or unstable for its intended purpose. The functional failure of a mechanical piece of equipment resulting from a manufacturing defect often require immediate correction. Likewise, the functional failure in the building may be caused by lack of maintenance, lack of oversight by the engineers over the workers during the construction. And then functional failure can originate from design errors, manufacturing errors, installation and commissioning errors, and operating and maintenance errors. And let's see what are the general functional failures. That is lighting problem due to bad orientation of the building, that is a functional failure. Improper thermal insulation and incorrect ventilation is a functional failure. Then sound insulating system is not proper, that is also a functional failure. These are the general failure situations, general failure condition of the building. Now we are moving on to the causes of failure in a concrete structure. So that is also a very important topic. So what are the causes of failure in a concrete structure? So the first thing is accidental loading. That means it can be defined as a load which the building is usually not designed for. Okay, suppose if the building is designed to handle certain loads and some unexpected loads come over the building than which has been already foreseen and the building has been designed based on that. If such loads are again coming on that building, it may that is accidental loading. It may result in the failure of a concrete structure. Then improper transfer of load. So due to the proper centering and due to the poor workmanship, this the load transfer might not be proper. So that is another reason for the failure in a concrete structure. So next aspect or next reason for the failure in a concrete structure is chemical attack. So in the chemical attack, the first one is acid attack. That is, the concrete is susceptible to acid attack because of its alkaline nature. Components of cement paste break down during contact with the acids. So this will result in the failure of the concrete structures. Then next one is alkali silica reaction. That means reaction occur between the highly alkaline cement paste and reactive non-crystalline silica. Next one is sulfate attack. Okay, the sulfate react with calcium aluminum hydrate to form calcium sulfur aluminate, and these products have a considerably greater volume than the compounds that they replace, so that the reaction with sulfates lead to expansion and disruption of the concrete. Next point is due to correction errors or poor workmanship. That means unstable formwork, misplaced reinforcement, improper mix design, error in handling and placing concrete. That is the construction error or the poor workmanship errors. Next error is for like improper quarry. If poor concrete mix and water quality of all building materials needs to be checked before mixing. Then next point is corrosion of embedded metals. When steel corrodes, the resulting rust occupies a greater volume than the steel. This expansion creates tensile stresses in the concrete, which eventually will cause the failure of the concrete structure. The another aspect for the failure of the concrete structure is design errors. It includes errors in computation, failure to account for loads, ignorance of the effect of stresses, improper choice of materials, etc. The next is the next aspect which causes that concrete failure of the concrete structures is poor design details. That is, re-entering corner, abrupt changes in the section, leakage through joints, etc. The next important reason for this error in these concrete structures is erosion. So erosion is a result of continuous contact of concrete structure with still or moving water, wind and continuous traffic movement. This result in the corrosion of steel. Okay. Then freezing and thawing. All concrete is porous and will absorb this moisture. The moisture freezes and expands and causes the concrete surface to crack. The next point is settlement and movement. Next point is due to shrinkage, and next is due to temperature stresses. So these are the main aspect for the failure of these concrete structures. This failure of the concrete structure is also very important. Then now let's see what is the failure in steel structures. So this structural engineer, that means design elements of a building to resist a wide variety of forces. The different types of forces experienced by the steel structure in a building includes shear forces, compressive forces and tensile forces. So every steel structure should be correctly designed to resist these forces. Steel is a strong material and leads to manufacturing of slender members. So basic reason for failure of steel structure is failure of connection, that is shear failure. So designing a connection is not an easy task. A failure can occur if the structural engineer underestimates the design forces the connection has to withstand. The common connection in steel structure may be made with bolts or welds or a combination of both. So that is a connection failure. Next failure in a steel structure is failure of the beam, which is otherwise known as flexural failure. That is, the beams typically fail when flexural loading causes high overstress or if the beam buckles. This flexural loading creates tension and compression forces in the beam. Then lateral torsional blocking occurs when the high compression forces causes an unrestrained section of a beam to buckle and laterally displace. So providing lateral restraint to a beam helps to ensure it will not buckle. So extra protection or extra support should be given to it so that this buckling problem could be removed. Then failure in compression. That is another aspect which results in the failure of a steel structure. That is, applied load on a structural member causes a compressive stress. Likewise, similar to beams, column members subjected to high compressive stresses may also experience this buckling. The another factor is failure in tension. Basically, this type of failure occurs when the steel member is stretched to a level that exceeds its ultimate capacity. This occurs in stages. Okay, the first yielding, then necking, and then the material fails at a point with least cross-sectional area. So these are the aspects which are affecting the building failure. And so we have seen the general failure conditions and what are the factors which affect the concrete structure to fail, what are the factors which affect the steel structures to fail. So this is a first part of our module 6. So go through the PowerPoint presentation and my video presentation clearly so that you can attend the classes and you can go through the PowerPoint presentation and you can make notes based on this. Okay, so study well. So maybe we can complete our 6th module in another 2 or 3 days, and then we can slowly go back to our previous modules, 4th, 3rd, 2nd and 1, so that you can complete the portions and study the portions and keep this subject aside. So thank you for the cooperation which people are giving me, especially in this situation. You are helping me to take the classes in such a manner that I hope you are getting some benefit out of it. So kindly do cooperate. So let's face this challenge of not having our regular classes by this method. So hoping my children will study well. Okay, and we will discuss the questions also. Thank you. So next day we will move on to the second part of our 6th module. Thank you.